triangle? Does anyone remember? Just the general formula for the area of a triangle?
It's like a side times a side divided by...
No. The one you already knew before you took this class. Just the area of a triangle.
I don't know.
Somebody knows. I know you guys know. What's the area of a triangle?
I know it's something times 1/2.
Okay. That is true. Okay, so let's start even further back. Let's see. What's the area of this?
Like
And then the area of a parallelogram is base times height. And very quickly, can you imagine if I took this triangle and I just cut it and put it over here, wouldn't that make a complete rectangle? That was B by H. Okay, so the area of a parallelogram is base times height, and a triangle is exactly half of a parallelogram. Okay, so the area of a triangle is half height base, no treble. Yeah, stop. So you guys knew this. I know you knew this. Somebody knew this. Okay. So if I'm given a triangle and I'm given an angle, let's see, doesn't matter. It's just an angle and then two sides. And I want to know the area of this triangle. If I drop this down, this is the height, yes? You guys kind of with me?
Yeah.
What is this height in terms of these three things here? I mean, what relates these three, h, theta, a? What trig function of theta do I take to relate h with a? Say again? Sine, yes, cool. Sine likes the y. So isn't the height a sine theta? You guys kind of with me? So the height would be a sine theta. The area of a triangle is 1/2 the base times the height, but the height is a sine theta. So the area of a triangle, if I know two sides and the angle between, the area is 1/2 multiply the two sides, sine theta. That is just a formula you can chuck stuff into. It kicks so much ass. A and B, those two sides, the theta must be the angle between them. Is that, you guys with me? Okay. And this is a little side note. It's just a really quick little, any of you guys could do this if I would have forced you to, because you always look for a right triangle, and the quickest way to get a right triangle is just to drop a straight line down to one of the straight sides. And then when you do that, you got a right triangle, and now you can set up relationships. No, so then that problem becomes stupid easy, because they gave us two sides, they gave us the angle between, you just got to throw them in. Is that all right? Okay. So not overly concerned about that. It's just a quick little side note, and then when you get a problem, it does just become plug and chug. So like on number 27, beta is the angle between A and C. So then you have to just throw that stuff in there, right? Just be really careful. We're better than this, so like, that's the general formula. So if I want to write it a little more for any situation, 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. I mean, do you guys, I need you to understand, those are all the same formula. They're all the exact same formula.
Is it always going to be sine?
Yes. Because sine is what gives me the height when I make my right triangle. Yeah. Not too bad. So again, I'm not going to worry too much about this formula. If you want to memorize it on top of all that other stuff, you can. I don't need it to. Yeah. Okay, anything else from homework stuff? So the quiz tomorrow, law of sines, law of cosines, first 2 sections in chapter 10. So definitely get in there and get some practice if you haven't done so already. What's the quick way to tell if you can do law of sines?
Sides and angle.
Yeah, you have to have a side and the corresponding angle known.
Oh, okay.
Because then you can set up a complete ratio, right? It's all about trying to set up an equation where I only have one unknown. So if I can't make a complete ratio, every equation would have 2 unknowns. It's no good. Okay. Anything else from 10.1, 10.2? Okay. 2, 4, 6, 8, 10. I'm sad that I'm happy that I hit double digits, but it's okay. All right. So last time, if there's no questions, does anyone need the handouts from yesterday? So we did this worksheet. Oops. This worksheet we did. And then we have this guy that we started on. More people. All right. So let's come back to this worksheet here. Just for the benefit, everybody who just came in, just to remind you guys, and you've known about this for a while, just a reminder, we have a quiz tomorrow. 10.1, 10.2. Okay. Oh, sorry. What are you trying to take a picture of, Mike? This here? Oh. Okay. So we developed these formulas yesterday. It's amazing. We started doing this second problem. Let's finish up this second problem, then we'll come back to these freaky things here. Let's see, where did we end up? A, B, C. So if you weren't here yesterday, the way that polar coordinates works is the angle tells you which way to face, and the number in front is the R. It's how far to go. This is the craziest thing. The scale, we're so used to XY being on these straight lines, but now my R scale is these circles as they go out. So one scale is rotation, and the other scale is going out. So literally, it's kind of like taking the XY plane and folding it on itself. So we did A, B, and C. So let's do D together, just to kind of remember how this works. So to get to point D, which way do I face? 5 or 6. I look at 5 or 6, and I go out
1.5.
1.5. So 1.5. So that would be point D. Now, part E, what's going to be a little different? I mean, which way do I face? 2 pi. I look at 2 pi over 3, but I'm going to go back -3. Now, what really sucks is it's really hard to tell which way the line goes, but you see what I mean? It's kind of like this line. Where does it come out the other side? But if that's 2 pi over 3, and I go back, I should be approaching the reference angle, the pi over 3 one. Does that make sense? If I'm looking at 2 pi over 3 and I want to go backwards, do you all understand it's not the easiest thing in the world to see where that line goes? You could put a ruler down and kind of tell. Or you could just realize if I'm looking at 2 pi over 3, I'm gonna walk back towards 5 pi over 3. It's gotta be the same reference number, right? So I'm gonna look at 2 pi over 3, and I'm gonna go back 3 steps. So what's an immediate other way to write this point? How would you designate that point instead of having a negative r?
3, 5 pi over 3, 3.
It'd be 3, 5 pi over 3.
Yeah, that.
Yeah. And Mike, I agree with you. I wish we would have put theta first. That would have made so much more sense, but we didn't. Too bad. Do F real quick. So in this one, I'm going to look, where am I going to, negative 11 pi over 12. Where is that? Which quadrant would it be?
Quadrant 2.
Quadrant 4.
Well, it's currently in quadrant 2 with the negative.
So I've got to go
End up
back,
being in quadrant 3.
I've got to go back 11 pi over 12, correct? So negative 11 pi over 12 is just below of what? Negative 11 pi over 12 is almost what?
0.
Pi.
It's almost
Pi.
negative pi. Yes? It's 11/12 of a pi. Isn't that almost a full pi? So I almost go back a full pi. How far short am I going to stop of a full pi?
Just one
One what?
little area.
Oh, well, okay, gotcha. So yeah, I'm going to rotate back and I'm going to stop here. So this will be pi over 12. I'm pi over 12 short of a full pi. What's another way to do that, guys? If I take negative 11 pi over 12 and I add a rotation, isn't that a coterminal angle? So if I make this over 12, this would be 24 pi over 12. What's 24 minus 11?
13.
Holy shit, 13. So one way to do it is I want to go back, not quite a full pi. I'm a little bit less than a pi. I'm exactly pi over 12 less than a pi. So I'm going to go here. I'm going to be looking at this angle. And then I'm going to go... Why would I go opposite? The 2 is positive, so I'm going to move in the direction I'm looking. 1, 2. So I'm going to tell somebody where to look. If the R is positive, I'm going to walk forward. If the R is negative, I'm going to walk backwards. Okay. All right. Any questions on that? I'm going to post in Canvas. I need to create a series. I'm going to try to make a PDF that you can print out if you want to, of just a bunch of blank ones of these. Right, so you can do your homework a little bit easier. You could just search the internet for polar graph. Go to images, search for polar graph. You can download it. You guys kind of with me? Yes? If I, guys, help me out. Negative 10 degrees. Negative 10 degrees. What's the positive angle? What's negative 10 degrees? Guys, look at me, look at me. What's negative 10 degrees? Where is that? Positive angle. Give me a positive angle. It's the same thing as negative 10 degrees. 350. How Does everybody agree with that? How did you get that? You added 360, correct? If I add 360 to any angle, don't I get a coterminal angle? That's the whole idea of the plus or minus 2 pi k business, yes? Is everybody with me? 360 in degrees is, of course, how many radians? 360 degrees is how many radians?
2 pi.
2 pi. So if I have negative 1 pi over 12, how can I get a coterminal angle? I can add 2 pi. Isn't 2 pi 24 pi over 12? Personally, I wouldn't do that shit. I wouldn't. I don't need to. Do I want to go back to full pi? If I want to go back to full pi, I go here. If you're looking at this. I don't want to go back to full pi. I don't want to. I'm going to go 1/12 of a pi short. So of course I'm going to be staring at this dude. So there's 2 ways to figure out you should be staring at this guy. The R is positive, so I'm going to walk in the direction I'm looking. If the R is negative, I'm going to walk back from where I'm looking. Don't let polar coordinates be difficult. They're not. They're not. The angle tells you where to look, and the R tells you if you want to go towards that or if you want to go away from that. That's it. Let that be nice. Okay. Maybe. So ready? Okay with that? You guys got that? So looking up here, real quick. I always have to give you an idea of what coordinate system I'm in to begin with. Just like if I say, what's the sine of 30? Why can you not do that without a calculator? Why can you not do sine of 30 without a calculator? Nope, you sure cannot do sine of 30 without a calculator. Because what units is that?
Well, it would be radians.
Radians, there you go.
Because if it were degrees,
I would have said degrees. Yeah. So on these problems, I always have to give you an idea of what coordinates you're in currently. So number 1 says convert to rectangular, so I must be in polar. So can somebody tell me in 1A, what is the 2? What does it represent?
Radius.
It's R, 11. So each of these are going to be R theta. So R is 2, theta is 5 pi over 3. And I want it to convert to rectangular coordinates. So look, polar to rectangular. So for part A, how would I get x?
Radius cosine theta.
R times cosine theta. So R is 2. Theta is 5 pi over 3. Maybe? Do you guys with? So again, cosine likes x. It makes sense that x is our cosine theta. Because cosine theta would be x over r. We've known that forever. So of course x is our cosine theta. So to be honest, none of this shit is new. We're just using it in new ways. None of this is new. We're using it in a different way. What is cosine of 5 pi over 3? What quadrant's that? What quadrant is 5 pi over 3? Fourth quadrant. All I knew was one person saying one first quadrant would have been all the quadrants. How do I know 5 pi over 3 is in the fourth quadrant? Because 6 pi over 3 is 2 pi. So I'm 1/3 of a pi short of it. So of course I'm in the fourth quadrant. Is cosine positive or negative there? Positive, because x is positive there. I like it. And of course, what's the cosine at any pi over 3? Any reference angle pi over 3? What's the cosine? 1/2, 11. So that's just twice a half, yes? Okay. This is where it's going to suck if you never actually took the time to remember what the hell cosine of 5 pi over 3 is. You can't do this shit. So 2 times a half, 1. So what's y going to be? Yeah, 2 times sine 5 pi over 3. What's sine of 5 pi over 3? Good, it's negative because we're in quadrant 4. Say it again. rad 3 over 2, so I get negative rad 3. So this point becomes the point 1, Jeff, don't look at the monitor, 1, negative rad 3. Let me see, I'm going to do something, gosh, if I could just write, everybody would be so happy. Two things I want to ask you. What quadrant did we say that was in, of course? Fourth quadrant. What quadrant is that point in? Positive x, negative y. Positive x, negative y. It better be, correct? Because that point and that point are supposed to be in the same place. So one quick check at the end is that's fourth quadrant. That better frickin' be fourth quadrant, or you've done something wrong. Normally you've forgotten negative. Does that make sense? You always want to know, how do I check my work? Dear God, Jeff, tell me there's a way to check my work. Let me see if this can make sense. Let's see. What is square root of 3? Let's see if I have it memorized. I try to have it 1.73. What's square root of 3, guys? Somebody help me out. 1.73. Okay. Now, just bear with me. Has everybody got that? I'm gonna put this. I'll bring it back in a second. Do I have more of these? I do. Okay. So real quick, just side note, just real quick here. If I graph 2, 5, pi over 3, that's not very hard. I'd look at 5, pi over 3, and then walk out 1, 2. Now, let's see if you guys are cool with this. If I trace this back to the x-axis, do you see how the x-coordinate is just over 1? Yeah. And actually, it's probably see how I went out? So it should exactly be 1. You guys see that? If I go straight up from this, the x part is 1. You guys with me? Yeah. And isn't that what we frickin' got? Okay, now if I trace it straight back to the y-axis, isn't it just below 1, 2? So doesn't it, I can't tell from my crappy little thing, it's too small, but it being negative 1.7 something makes visual sense, yes? Okay, I don't know if you guys are really all with me, but this is a visual translation. If I just plot 5 pi over 2, if I just put it there, I can kind of just see, okay, what x value, what y value does it look like it is? I can never get the exact answer that way, but that's a kick-ass way to check the work. So if you got 1 comma negative 4, you're like, no, shit, I did something wrong. It should be below 1, 2. It should be below 2 for the y part. Okay. And again, that's extra. That's how to check. That's what this means, all this kind of stuff. Okay. So you guys do part B real quick, if you haven't already. I gave so much room on this worksheet, so you might have to use another sheet pick. Has everybody got this sheet? Anybody need? Yes, okay. Oh, shoot. Here. Oh, you need it too? Okay, hold on. Good try. It's not my time. So again, this really kicks so much ass to, if you know the cosine likes x, sine likes y. So how do I set up for x?
So minus 12.
Yeah, and r negative 12 times
Cosine, 7 pi over,
6. Yep, okay. And real quick, what quadrant is 7 pi over 6? Third, so both sine and cosine are going to be
Negative.
negative, good. And then over 6, what's cosine at any over 6 reference angle? Yeah, root 3 over 2, kick ass. 2 goes into negative 12 6 times, so I get negative times negative is positive, I get 6 rad 3. Crazy sauce. Why? Negative 12 sine 7 pi over 6. So it'd be negative 12 times negative. The beautiful thing is if cosine's rad 3 over 2, sine's got to be 1/2, right? And that'll become positive 6. What quadrant does this end up being in this point? This is in the first quadrant, yes, because they're both positive. Is this point in the first quadrant? Think about it. I'm facing 7 pi over 6, correct? I'm facing 7 pi over 6, and then I'm going back 12. There we go, cool. So I am in the first quadrant. I have to be in order for the answer to be correct. That's in the first quadrant, that must be in the first quadrant, but I can check. And sure enough, if I look at the third quadrant and I walk backwards, I look at the quadrant, I'm like, I don't like it, I start walking backwards. I'm in the first quadrant. Yeah, I like it. Okay. Now, let me ask you this. Anywhere in the universe that I see r cosine theta in polar, what is that in rectangular? What's r cosine theta equal? X. Anywhere I see r cosine theta, when it's in polar, I can replace it with x. Anywhere I see r sine theta, I can replace it with y. Look at number 2a. Can you tell me what's missing? What do you wish was in front of the sign? Could be a y, because I have to be in polar here. What do you wish was in front of the sign?
Negative.
R.
An r. If only there was an r in front of the damn sign, I could just replace r sine theta with y. So if I see a poor little cosine all by itself, and I'm supposed to translate it to rectangular, I'm going to multiply by r, so then I get r cosine theta. That's freaking x. That kicks ass. I need you to understand. So let's do this. Let's do this. Let's do a simpler example here.
Oh,
If I had r cosine theta plus r squared sine squared theta equals 3. What's r cosine theta in rectangular? So this is polar. I want to take it to rectangular. What's r cosine theta? What's r cosine theta?
X.
X, right? R cosine theta is x. This is r sine theta squared. What's r sine theta?
X.
R sine theta.
Oh, Y.
Y.
Y squared.
There, I took a polar equation and I converted it to a rectangular equation. If I plotted this in polar coordinates, it would look exactly the same as this. You guys with me? If I had an equation, let's do another one. 2 r squared equals tangent theta. I like it. You would, Jeff. What is r squared in terms of x and y? Look at your paper to help you out. Yeah, so if I see an r squared sitting somewhere by itself, I can replace it with x squared plus y squared. What's tangent theta? And this is what we know
X
forever.
over Y.
Y over x.
Y.
right? And then you can multiply by x. I don't need too much simplification, just don't leave a fraction in there, you know. So this is started totally polar, yes, this is totally polar, totally. And then I made it into a completely rectangular, right? So if I ask you to convert this equation from one form to the other, it's got to completely be. I don't want any thetas or r's left if I want it in rectangular. And it's really not that evil, because you know what to look for. You look for these things. So this first one, how do I make an r show up there? Because I want an r there, because if there was an r there, then I could put a y there. How do I make an r show up here? What do I do to both sides to make an r show up here?
Subtract.
If I divide, I have an r underneath.
Subtract r from each side.
I love you guys. So let's try to multiply by r.
Oh,
Doesn't that make an r show up there?
yeah, then you got r squared on one side.
Totally, which is fine. So what's r sine theta?
Y.
Y. And what's r squared? So it was polar. Is it completely rectangular now? Is it? No. Okay. Let me see if you guys. There's one thing I can do that would immediately let me write things in terms of y and x. One thing I could do to both sides. What would be in front of the theta that would let me immediately rewrite it in terms of y and x?
Tangent.
Tangent! So I just take a tangent of both sides. So what's tangent theta?
Y over x.
Y over x. And what's tangent of pi over 6?
That's.
So here's how I remember it. Tangent could be rad 3, 1, or rad 3 over 3, or 1 or undefined, right? Or, I'm sorry, 0 undefined. Tangent small when sine is small. Is sine small at pi over 6?
Yes.
Yes. So therefore, tangent small at pi over 6, rad 3 over 3. If you want to do that, which are rad 3 over 2. Yeah, it would be 1/2 over rad 3 over 2. You cancel the 2's, you rationalize the denominator, and then you finally get there. Yes. By the way, if I multiply the x up, do you see how this becomes a linear equation? What's the slope of this equation? Rad 3 over 3, yeah. So if you are going into calculus, two things I want to say before I forget. One thing is based on what I just said. In calculus, you're going to be doing stuff called finding the tangent line of something. So the slope is going to mimic the slope at a point. And you can see why. Look, the tangent is the slope of a straight line. That's what the tangent is. That's why we call it a tangent line, because the tangent is the slope. Wasn't the tangent rad 3 over 3? Isn't that the slope of that line? Okay, all right. Second thing I want to say. If you're taking calculus 1, math 180, we're offering it over the summer. I'm really sorry if you're tired of me, because I'm teaching that. I'm also teaching one in the fall. In the fall, we also have something called Math 180L, 280L. And that's kind of like a course you can sign up for, where in the classroom there would be no homework for that class. In the classroom, we would cover prerequisite skills. We would do some homework stuff. Does that make sense? And it's gone pretty well. This is the first time I'm going to be teaching it. I'm very excited to have a class where I don't have to grade any homework. That's number one. But number two is just being able to help directly with prerequisite skill knowledge that you're going to need for calculus. This makes sense. So that's an option for all students. If you want to sign up for 180L, 280L, when you take 180, you can, and then you can take it again if you take Math 280, Calculus 2. You do it again. It's crazy. Just to let you know. Okay. This guy anyone tell me the immediate thing that sucks about this, looking at all the options? What's the immediate thing that sucks about this, looking at all the options? It's secant. I ain't got no secants over there. I ain't got no good grammar either, so who cares? You guys with me? I ain't got no secant, so how do I want to rewrite this?
Secant is 1 over cosine.
So, that still sucks. Yes? That still sucks.
Doesn't suck as hard.
It doesn't suck as hard, that's right. How do I... This sucks. Why? Because my cosine is underneath. So, of course, what do?
Yeah, like...
No, yeah. How do I kill it so it's not in the bottom anymore and it shows up on the other side? Yeah, you multiply by cosine. So we got r cosine theta equals 3. And what's r cosine theta?
X.
X. There's my equation. X equals 3. Okay.
Oh, okay, that's good.
Does anyone know, looking back at part A, you guys know this, the unit circle, what's the formula for the unit circle? It's x squared plus, any point on the unit circle has to be, all right, what's the most basic Pythagorean identity? Sine squared theta plus cosine squared theta equals 1. Kick ass, right? If you replace those with x and y, you get x squared plus y squared equals 1. The unit circle, any circle in the frickin' universe has an equation that looks like x squared plus y squared equals a number. If I want to move it, I would then put like x minus 1 squared plus y squared. That would take the circle and move it forward 1. Because x minus 1, wouldn't that make it go forward 1? Yes? To the right 1? So that first one, 2a. This should be a circle that's been shifted, because if I subtract that over and I complete the squares and blah, blah, blah. So if I graph r equals 5 sine theta, it should look like a circle that's been shifted on the y-axis. So I think I have the other thing set, but I can change it easy. Doobie-doobie-doo. Let's make this sine real quick. What was it? 5, okay, sure. That just makes the radius go down. Watch, the radius is going to become 5. Pop. Well, not 5, but half 5. So it doesn't make sense. Sine likes y, so that circle is on the y-axis, correct? So if I make this cosine, if you're paying attention, I already had it there, it should go up on the x-axis. Isn't that silly? So real quick, going back to this one. Going back to sine. This is the section that I made extra credit, but I just want to talk about it real quick. 0 degrees is here. You all agree? This is 0 degrees?
Yeah.
What do I get when I plug a 0 in? 5 times sine is 0. What sine is 0? 0, so there be a 0 there. If I rotate to pi over 4, what's sine of pi over 4?
Pack 2 over 2 or rad 2 over 2?
Yeah, rad 2 over 2. Right? So that would be rad 2 over 2. That would be 5 times rad 2 over 2. If I put in pi over 2, if I look straight up, what's sine of pi over 2? 1. 1 times 5 is 5. So that's how you could graph a thing by hand. You make a theta r table. And you feed it theta and you get r's. And you just keep plotting the points. And then it, in this case, it's going to make a circle. Now watch this. You ready? Since I have this up here. What happens if I put a 2 in front of the theta? You guys know what fundamentally happens about sine if I put a 2 in front of it, in front of the theta. What changes about the sine? Sine 2 theta. If I told you to graph that, what's the period? Sine 2 theta.
It squishes.
Squishes, so the period becomes 2 pi over 2, it becomes pi, correct? So if I put a number in front of theta, the period changes. So visually what happens, watch this. How many petals does that have? 4. What do you think is going to happen if we put a 3 there instead? Nope. Haha. So what happened is here, the petals draw. So watch this kind of nifty. Real quick, if I put a 0, I get 0. If I put a pi over 4, in there, isn't that sine of 2? I really want you guys with me. If I put a pi over 4, twice pi over 4 is pi over 2. What's sine of pi over 2? Sine of pi over 2? 1. 1 times 5? 5. So at pi over 4, it's at 5. This is 5 away. And then if I put pi over 2 in, what's twice pi over 2? Twice pi over 2. Twice pi over 2. Pi. And what's sine of pi? Sine of pi? 0. So it comes back at pi over 2, it comes back to 0. And then it's going to do this. And then it's going to do this. And then it's going to do this. So that's how it constructs those leaves. If I put a 3 there, what happens is it'll do this, it'll do this, it'll do this, and then it's going to retrace these. So it doesn't do 6 because 3 of them lie on top of the ones that are there already. So what's your guess if I put a 4 there? When it was 2, it was 4 leaves. 3, it's 3 leaves. 4 is going to be
8 leaves.
8 leaves. Every even one ends up with double it. So 5 is going to have 5 leaves. 6 is going to have 12 leaves. 20 is going to have 40 leaves. Yes. 21 is going to have 21 leaves. Anyway, all right. You guys kind of with me? A little bit. Now, of course, you know, you can get all kinds of nifty, weird shit happening. That's not too weird, but then if I put a 2 in there, I get that again. But if I put in here a 2.5, you get some nifty things going on. 2.7 really gets nifty.
That's pretty cool.
I know. Sorry.
Like spirograph.
Exactly. Thank you. Sorry. I'll come back. And then if I put in here like plus cosine theta,
Is that called ancient
you start to get this weird offset stuff.
What's it called? Ancient geometry or something like that?
Yeah, sure. Or this always reminds me of the sand art that certain cultures do. Or yeah.
Mandala.
Yeah. So if I put a 5 in there, look, now it's getting totally freaky.
Wow.
That's just
If I make these match, it should be more symmetric.
That's gnarly, man.
Appreciate that. All right. Anyway.
Dude, you can make designs out of this.
Yeah.
Makes sense.
So this is what we keep saying, the spirograph game.
T-shirt company.
Say again?
Sorry, t-shirt company. Math t-shirt company.
Oh, it already exists.
Right,
That exists
right,
many times over, dude. I'm late to that game. Anyway, sorry. If I make these match, yeah, that gets weird. Anyway, so there's a lot you have no idea. In fact, yes, you do have some idea because on the back of this sheet,
Do you
I gave you these,
do you
right?
ever in our future there's going to be a professor that's going to make us make one of those on a graph?
Technically, you should do it in my class right now, but we just don't have the time. So I made that section extra credit. But you can certainly do this. You would do this by hand, and it would work fine. You would do an R theta table. You put theta in, you get R out, and you plot each point. So we know how to plot points, correct? Therefore, I could just plot points that come from the equation, and then I can connect them. Whoop-de-doo. So it's not that big of a deal, but we just don't have the time. Okay. Anyway, okay. So what gets really nifty is last thing I'll show you. Just to remind you, it's kind of nifty playing around with Desmos. What time is it? Okay. If I do, If I put just letters in, I can add sliders. And unfortunately I don't mean, hamburgers or something. If I do this, then I can control the value of each of these. So you can see what happens if I change the coefficient, yes? So B looks to control kind of the size, and then at one point it kind of like the inside dude says, "My turn to be outside." Do you guys see that? The inside dude, my turn to be outside.
Yeah.
And this guy controls the kind of like side you're on the y-axis. See that? Now, real quick, at one point there's nothing internal yet, correct? And now, if I get to a certain point, now there's an internal little. This seems such like a bean where you have like a flower growing inside of it. It's like a little bean, dude. Yeah. Anyway, sorry. I can't remember what happens. Let's see. If you put a 2 here. Oh. Now that looks like you're having a trip. Okay. So there's a peanut. And I can make the peanut. All right, that's not, anyway. So you can have fun with a graphing utility. It's possible. Okay. Reminds me of squiggle. Okay. Coming back. Enough fun, damn it. So look at this guy. Convert to polar coordinates. So obviously I'm starting, let me get a fresh sheet so I can see what's going on. I'm starting in rectangular, and I want to go to polar. So I'm trying to help you out here, rectangular to polar. To get r is easy as hell. Because I know the x, I know the y, so of course the r is this hypotenuse, is Pythagorean theorem. It's r squared is x squared plus y squared. So how would I get r then? R squared equals?
X squared plus y squared?
X squared plus y squared. R squared equals 3 plus 1. 4 square root is 2. R can be negative, but when we're doing this, we normally pick the positive one. And how do I get theta? How do I get theta? I could have written this like this instead, but I just didn't. Right? Don't I take the inverse tangent to solve for theta? So here I need to know what the inverse tangent of what over what. What's tangent? What over what? Y over x. So it'll be y over x. We actually just did this a minute ago. Does anyone remember what angle that was that makes the tangent small?
1/2.
No. What angle makes the tangent small?
30 degrees.
5 or 6.
Yeah, that
Tangent small when sine is small.
angle.
You guys do part B.
Negative.
Just in case anybody came in after I did this reminder. Okay. There. Why did you do that? Someday I'll get there. Okay. Here, we have a quiz tomorrow. Right, 10, 1, 10, 2. That's law of sines, law of cosines.
Okay, so I got a question about that.
About the one we're doing?
Yeah,
Yeah, what's up?
okay, so I can look at those particular things, and I can see that that's like 3 pi over 4.
Yeah, totally. So sometimes,
But where do you get the radius?
oh, radius, you get it. If you know x and y, the radius is relatively straightforward. You just take the x and you square it, and you add it to the y squared. R squared is x squared plus y squared. R squared is x squared plus y squared.
Oh,
So what do you get? What's rad 2 squared? 2. 2 squared 4, so you get negative 2 fourths, not negative, it's positive. Plus, same thing, so I get 1. And like Mike said, I don't have to do this all the time. When is cosine negative rad 2 over 2 and sine positive rad 2 over 2? What quadrant is this in?
4.
I have a negative x and a
It's in the
positive y.
second.
Second quadrant. So my angle's got to be in the second quadrant. And I know it's going to be what angle? 45 degree, pi over 4. So what pi over 4 angle is in quadrant 2? 3 pi over 4. R is 1. So you don't always have to use the full formula. If you can just, oh, I know what angle that is. I know when cosine is that and sine's that. I don't have to do the whole tangent inverse thing. Now, for A and B, let's look at 4A. I want to convert that to polar. This is normally the easier way to go because you know exactly what y is, you know exactly what x is. In polar, what's y in polar? Yeah, so this will be r sine theta equals 1 over, and what's x? Or cosine theta. And if I multiply that up, I get r squared sine theta cosine theta equals 1. And you can stop, that's fine. Now, there's one thing on part B, but people make a mistake on this part B, is they start throwing r cosine theta, r sine theta. Can you see one thing I could do to get something really simple to show up? What's r squared again?
X squared plus y squared.
Can you make that show up? Can you do something to make x squared plus y squared show up? Add y squared, yeah. So if I add y squared to both sides, I get x squared plus y squared equals y over x. What's x squared plus y squared? R squared. And what's y over x? Change. Shema! Done. Write English stuff, that'd be neat. Okay.
Awesome.
So what you need to add to your overflowing brain are these things. And the beautiful thing is, none of these are new. So to be honest, you don't have to add shit. You already know this, you already know this, you already know this. You were just using them in a different way. Yeah.
4B was just r squared equals 2.
Yep.
Okay.
I started off with x's and y's. Now I have only r's and thetas, so I know I'm done. And you always kind of do any simple simplification. You don't have to take a square root, put a plus or minus. Don't do that. Okay, all right. So you got to get in there. You got to try that stuff out. Okay, so any questions on that before we get into the next thing, like we do? Okay. All right. So real quick, just to help you guys out, a valid question could be, hey, can we do a couple more examples of that? But if there's no questions, we're going to get into the next stuff. Oh, okay, sure. It's amazing. Sorry, I love you guys so much. So I hope to God I don't come off as somebody who you can't just ask stuff, and I'm sorry if I do. I try not to. It's up to me to say, we ain't got time. You can ask me any damn thing. And it's my job to say when I don't have time. Focus. Okay, so what kind of problem do you want to do? Be a little more specific. Which type of thing? Is everybody okay with the graphing stuff?
Oh, yeah.
This should be like, dear God, give me a lot of this shit,
What
Jeff.
section is it?
10-3. All this is in 10-3. So you want to do more like these, I guess, right?
Yeah.
Okay. So let's see, what about, what if I had, yeah, let's do this. Let's do, here's a good one. R equals 7. And I want to convert that to rectangular. Right? All rectangular means is x and y. Bless you. Bless you. What the hell do I do? What do I wish I had written there? What do you guys wish I had written there? R squared, right? One way to make r squared happen is to multiply both sides by r. Why would that suck? Because then the other side would have an r, and that was the problem in the first place. So what's a better way to make an r squared? Square both sides. So now you get r squared equals 49. I need you to understand. You know what you're looking for. Bless you. You're looking for, bless you. You're looking for tangent theta, you're looking for r squared, you're looking for r cosine theta, you're looking for r sine theta. If it's almost there, do what's going to make it show up. So I could have multiplied both sides by r. That would have made r squared, but then I would have had 7r, and there's no sine theta, cosine theta. So instead, I'm going to square, and then how do I rewrite this? This would be a circle of radius 7, which is what that is. What does this say? What's r again?
7.
So does it say radius is 7? So this should be a circle of radius 7. That's what that means. R equals 7. And sure enough, just to give you multimedia whiplash, turn this off. If I put r equals 7, bam, I get a circle of radius 7. It's crazy. Okay. I needed to make sense. What's x equals 6? If I graph x equals 6, what does that become? X equals 6 on an xy plane, if I graph that. I didn't want this to be a hard question. X equals 6, what does that look like?
Well,
Straight up and down line, right? Because x equals 6. X is constant. Y can be whatever it wants to be. This says r is 7. So that's 7, correct? R equals 7. Does it say anything about theta? So theta could be whatever it wants to be. So it's just 7 no matter what theta is. So of course that makes a freaking circle of radius 7. Okay, maybe. The same way that x equals 6 has no restrictions on y, so of course it makes it a straight up and down line. Stay with me. Let's do another point, I guess. Let's see. Let's do one that's a little bit freakier. Yeah, -2, 1. What quadrant am I in? 2, because you go back 2, up 1, so I'm in quadrant 2. How would I get r?
x squared plus y squared.
Good. X squared plus y squared equals r squared.
That's going to be 4 plus 1 is 5.
So r is
Rad 5.
rad 5. Cool. And then how do I get theta?
Tan.
That's y, right?
All right. Is that an angle you know?
Yeah. Oh.
Because it's tangent.
No.
If it was sine or cosine, I know 1/2. So you have to throw this in the old calculator. Right? What do you get when you throw that in the old
5
calculator?
over 6.
No, because tangent cannot have a 1/2 output for our
Why don't
angles.
you use regular tangents? Why do you use inverse tangents?
What's the formula? Tangent theta equals y over x. I want to know what theta is, so what do I do to both sides to get theta by itself?
You to eliminate tangent, you do the inverse of tangent.
There you go. So theta is the inverse tangent of y over x. Okay. So anyone have a calculator? I want to do this. Inverse tangent is -1/2.
Negative 0.464
Okay? Is that what everybody's getting? Or is anybody else doing that?
Or is it supposed to be in degree or radian?
Doesn't matter. Well, degrees, for the most part, yeah, we should be in degrees. I'm sorry, radians. What did I just say? Oh, we should be in radians. So inverse tangent of -1/2. Yeah, so I get that. Radians, -0.46. Now, can somebody tell me, so I'm going to round it. Can somebody tell me why that's definitely not the right answer? What quadrant would that be in? What quadrant would that be in? So I'm going negative, and I'm not going one, remember, what's pi again? In decimals? Pi? 3.14, what's half of pi? About 1.5, right? 1 point, you with me, 1.57? So if I go back 0.46, I haven't gone all the way to this here. So what quadrant am I in? Fourth quadrant. What quadrant was supposed to be in? Yeah, so what can I do to get to quadrant 2? I can just add
Pi.
1/8. Pi, yeah, so I can add pi. So to get the correct angle, this is the reference angle. To get the correct angle, I can do -0.464 plus pi. And of course, you just do that on the calculator. Plus pi. 2.678 roughly. So you will, every now and again, get a situation where it's not an angle that you know. You have to use your calculator to figure it out. I desperately need, the minute I give you a point, you know exactly what quadrant you're in. From the beginning, I knew what quadrant I was supposed to be in. So when I get here, I'm like, oh shit, that's not the right quadrant. Let me get it in the correct quadrant. I don't know if you guys remember, inverse tangent, what's the outputs for inverse tangent? Negative pi over 2 to pi over 2. Inverse tangent. Yeah.
How do we know what quadrant it's supposed to be in?
Right here, -2, 1.
Oh, that's the same problem. Okay.
Yeah, this is all the same problem. So I know that point's in quadrant 2, and all I am doing is renaming the point. So whatever point I get as an answer better also be in quadrant 2.
Okay.
Okay. Real quick, if this would have been 2, -1, what quadrant would that be in? 2, -1.
Quadrant 4.
Quadrant 4, I could have stopped here then, because this would have been the exact same work. Do you understand? It would have still been -1/2. I would have still gotten this, but it would have been the right angle. I could have stopped. Okay. So the big thing is just these formulas, these conversion formulas. These are not new. We're just using them in a different way. Okay. Now, so section 10, what was it, 10, sorry. Yeah. 10.4, good. So 10.3 is polar, 10.4 is polar graphs, where you get to graph those things by hand, the kidney bean graph and all that kind of stuff. So you can do it if you want to. And then 10.5 is where we do something kind of trippy. Let's see. That's all we ever do, Jeff. Okay. Do you guys remember? So guess what's coming back? Guess what's coming back? Okay. Can somebody remind me the idea of complex numbers? Where are they? Do you guys remember? So like if I multiply by -1, I do a full rotation around. Right? 1 times -1, I go all the way over I do like pi radians, don't I? Don't I make a half rotation? So if I multiply something by -1, that is a half rotation. Do you understand what I'm saying? You never had to look at it. We're not going to teach somebody who's 6 this. Well, you just rotate it by half. No, we're going to say negative times positive is negative. But now we can be a little more precise about it. So if I multiply by half of negative 1, I'm going to go halfway. And that would be complex number. So you guys remember, I showed you that, didn't I show you that video with the guy who picked up the, you guys remember I picked it up, it was all colorful? Because the complex numbers live on the side of the axes. So this is the x-axis, this is not the y-axis. This is the complex axis, which is what he lifted it up into. So if you graph something and you have an x-axis, this axis would actually be out here. But of course it's hard for me to draw that, so I just slam it on there. So, just to show you a couple things. So this is the real axis, this is the imaginary axis. To show you a couple things. If I wanted to plot the number, and real quick, just to introduce this now, we use the letter Z to represent a complex number. So if I wanted to plot 4i, does that have any real part to it?
4.
Okay, let me do something. Here's a complex number, a plus bi. What would you say is the real part?
A.
A. And what would you say is the complex part?
B.
B. So B. Does this have a real part?
No.
Nope, because it's 0, yes? So I'm not going to go on the real axis at all. I'm going to go on the imaginary axis there. That's where 4i is. Which is why when we graph stuff, when I graph x squared plus 1, I don't see the x-intercepts because they are out here. So that's why when he lifted it up, you could actually see it hit because it hits out here. We normally just graph a slice of this shit. We graph the real slice. Okay. So watch this. How do I graph z equal 3 plus 2i? You could do this. How far do I go out on the real axis? So on one level, let this shit be easy as hell. So right now I know you all are freaking out. I'm lifting shit up and getting colors, going to different dimensions. Dear God, Jeff. But on the other level of this is easy as shit. This part right here. 3 real, 2 imaginary. There it is. 3 real, 2 imaginary. Yes? Okay. Lock it. Do you guys see, now some of you guys might be wondering right now, why the hell are we doing this? Seems totally unrelated to what we just did. Does anyone notice this is completely what we just did? Can't I write this in polar coordinates?
Yeah.
What would the R be? R be. By the way, let me take these eyes. We normally don't put the eyes there. I'm just being more specific. So this is 1 unit up on the imaginary, 2, 3. How would I get R? R squared equals?
X squared plus y squared.
Yeah, and to be a little more precise, I'm going to say a squared plus b squared for this. R squared equals 3 squared plus 2 squared. So R squared equals 13. So R squared is 13. Yep. So this is 13. Square root of 13. Whee! And what's the angle? Inverse tangent. Here's what's cool. It's going to always be the imaginary divided by the real, because the imaginary is like the y-axis in a way. So it'll be the imaginary divided by the real. And of course, you could just do that in the calculator, right? You guys seem very excited about this prospect, but on one level, I want you to understand it's just plotting points. On the other level, it is then converting to polar coordinates, which we just learned, but that's not that evil, right? Get the r, get the theta. Okay. All right.
For that, it needs to be in radians?
We're gonna use radians. Yeah, we kind of leave degrees behind because their usefulness is very short-lived. Yeah. So watch this. If I am given a point that represents a complex number, right? This will be like, how do I say this? Sure, okay. So if I'm given a point x plus iy, okay. You guys all with me? What's x in terms of theta and r? We know this. What's x in terms of theta and r? We know this. X equals r cosine theta. And what's y? So that's the complex number. That's the complex number. So I can represent a complex number as cosine theta. You pull an r out, which we're trying again, Jeff. R times cosine theta plus I sine theta. So this is what it looks like in rectangular coordinates. This is what it looks like in polar coordinates.
What now?
Okay. Now you can do some funky shit with this. Let me show you one thing. Show you one thing we can do, and then I'll let you out of here. So if I say I have two complex numbers, Z1 and Z2. By the way, don't let this freak you out. What's r times cosine? It's just freaking x. What's r times sine? It's just freaking y. So this looks very complicated or whatever, but it's just one step away from just being x plus iy. That's all this is, right? But here's where this becomes really useful. Let me see if I can do this semi-quickly. If I multiply these together and stop looking at the monitor, there we go. This would be R1 times R2. Now just go with me just for, let me see, yeah, I got time. If I FOIL this out, I'm going to multiply Z1 times Z2. I'm going to multiply these together. I'm going to FOIL this sucker out. I'm going to get cosine theta 1, cosine theta 2, yes, this times this, plus I sine theta 2, cosine theta 1, plus I sine theta 1, cosine theta 2, plus, what's the last thing I need? Yes, these two. What's I times I? Which is? What's I squared?
-1?
Negative 1. Sine theta 1, sine theta 2. Now real quick, the stuff without an I. Poor little dude. The stuff without an I. Does that look familiar at all? Cosine, sine, sine. Cosine, cosine, sine, sine. With a minus. Does that look familiar at all?
Yeah, it's 2 cosine,
It's like 1?
or sine cosine, sine 2 theta, right?
No. Let me not forget my R1, R2. So, cosine theta 1, cosine theta 2 minus sine theta 1, sine theta is just cosine of theta 1 plus theta 2. It's just the sum. So what the stuff with the I stuff, what's this? Sine cosine plus sine cosine. Who was the nice guy? Sine. So to multiply two complex numbers, I just have to multiply their r's and add their angles. That's a little crazy. That's freaking cool. Okay. I don't blame you too much if you don't agree, it's okay. Alright guys, that's enough to do, that's plenty. So don't forget, we got a quiz tomorrow, 10-1, 10-2. Law of sines, cosines, yes?
So, we gotta after the sign.
Sorry? Come, I'm sorry, come up here, hold on. Yep. Because if I pull all these out, I get cosine times cosine, cosine times sine with an I, cosine times sine with an I, and then sine times sine. Right, I'm foiling those out, yeah. Yep, cool.
Let's go sign it.
Cosine theta 1, yeah, so I did cosine theta 1 times I sine theta 2, and then I did cosine theta 2 times I sine theta 1.
Oh, that's not the.
Yeah.